Hi students. So in this class we are going to discuss extensively about spring problems. Let's start with a simple example given. An elastic spring of mass, negligible mass, has force constant K. On one end of the spring is fixed to the wall. On the other end of the mass touches the block of mass. Mass is equal to 0.25 kg. And the spring constant K is equal to 40 Newton per meter. And one of the fixed the spring is compressed by amount. How much is compressed? X is equal to 5 centimeter. It is compressed. It's also equal to 0.05 meter. As shown in the coefficient of friction between the block and the horizontal surface, here is a mu. Mu is equal to 0.2. Now, if the system is released, find the speed of the block when it leaves the spring. Okay, coefficient of friction is given. See this question very carefully. Now the diagram is follows. It is compressed now. It is in a compressed position. Now how much is compressed? 5 centimeter is compressed. Okay. To do that, K is equal to 5. Sorry, it's 40 Newton per meter, and the friction force, downward force is mg, and upward force is normal. And we'll write the equation of work energy theorem. Now whatever we are going to do, we'll do the same way. Work energy theorem, work done by conservative plus work done by non-conservative plus work done by external force is equal to change in kinetic energy. Initially it is in the rest position. Initial velocity is equal to 0. Finally, when it loses the contact with the spring, but leaves the spring, how much it's compressed? 5 centimeter. So after the block travels 5 centimeter, then what happens? It leaves the contact. Now we need to know the velocity here, half mv square, and work done by conservative force. What are the conservative forces? Work done by gravity plus work done by spring force plus work done by non-conservative force is friction. External force is not there. What is the work done by gravity? Gravitational force is acting in which direction? Gravitational force is acting in the downward direction. Displacement is in this direction. How much is the angle? 90 degrees. So work done by gravity is equal to 0. Work done by spring force. Work done by spring force, what is the formula? Minus half K into xf square minus xi square. What is the final compression of the spring? Finally it is getting loose, right? K finally it is 0. Minus initially how much? 5 centimeter. We can write 0.05 meters, and we can K is equal to 40. It becomes a minus of minus plus K 40. If you substitute K 40 by 2, 20, and 0.05 is 25 over 4 zeros, and we can write 50001 so 1 by 20. Did I do any mistake? 500. Okay, so 2 5. Okay, 1 by 20 joules work done by the spring. Okay, now work done by friction. If you see the free body diagram, friction is in this direction. What is the value of friction? Mu mg. The displacement is in this direction. How much is the displacement? 5 centimeter. Work done by, what is the angle? 180 degrees. Work done by friction is equal to mu mg multiplied with 5 into 10 power minus 2. This is minus sign. Why minus? Because both are in opposite direction. Mu is given. What is the value of mu? Mu is equal to 0.2. I think mu is equal to 0.2 minus 0.2. M is equal to 250 grams. 0.250, and it is 10. 5 into 10 power minus 2. This is the work done by friction. Simplify the values. Now we will write the equation. Work done by spring force plus work done by friction is equal to half mv square. Substitute the mass value, get the value. We got the value of work done by spring is equal to 1 by 20. Work done by friction, will get a minus of some value. Get that value, minus half mv square. Only one unknown, that is velocity. Find the velocity. Let's go to the other question. Okay, next, a block of mass m is released from the rest from a point A. This is A. The block compression, sorry, the compression in the spring when the speed of the block is maximum. This one I discussed earlier in the classes. Speed of block maximum at equilibrium position. X equilibrium, speed is maximum. How to get the equilibrium position? To get the equilibrium position is net force is equal to 0. Now if you draw the diagram, in this m, in this direction, mg cos theta, in the downward direction, mg sin theta. When it touches the spring try to oppose its motion, so upward direction, the spring force is equal to kx. When the upward force is equal to there is a normal also, so now downward force is equal to upward force, mg sin theta is equal to kx. I'm sorry, wait a minute, where the angle is given, here is an angle theta, here will be 90 minus theta, so the sin theta becomes cos theta, this is sin theta. Now mg cos theta k into x equilibrium. X equilibrium is equal to mg cos theta by k. This is the position where we'll get a maximum velocity. Now there can be one more question can be asked. What is a maximum compression? Maximum compression. For maximum compression, what we are supposed to do? We are supposed to do energy balance. For maximum velocity, we should do force balance. For maximum compression, we should do energy balance. Let's start doing this. Initially, the compression, work done by gravity plus work done by spring plus conservative forces. These are work done by friction plus work done by external force is equal to change in kinetic energy. Initially started from rest, finally also it is in the rest, it is equal to 0. Work done by gravity, gravitational force. What is the gravitational force? Mg cos theta. This is mg cos theta. How much is the displacement? Say let's take x max is the displacement. Both are in the same direction or different direction? If you draw a diagram, free body diagram again, this is mg sin theta. I'm sorry, I'm writing every time cos sin theta only. Mg cos theta, and the displacement is x max. In the backward direction, okay, there is a spring force kx. Okay, maximum work done by gravity is equal to, both are in the same direction, force and displacement, it is equal to mg cos theta multiplied with x max. There is a plus sign here. Work done by spring force is equal to minus half k xf square minus xi square. What is the final position? Final position is minus half k maximum compression xm square. Initially is it compressed? No, it is equal to 0. Now substitute these two in the work energy equation in this expression. If we substitute here, now the expression will be mg cos theta into x max minus half k xm max square is equal to 0. Now x max square gets cancelled, x max is equal to 2 mg cos theta by k. This is the maximum compression in the spring. Remember, these are two different things, equilibrium and maximum compression. Don't be confused with these two. Let's see the other question. A block of 60 kg is released from the rest when the compression in the spring is, how much is the compression? 2 meter. Okay, you see these statements carefully. Natural length of the spring is 8 meter. The surface up to AB up to natural length of the spring, it's a smooth, there is no friction here, and BC is rough, here it is rough, and the block X travels X distance on a rough surface before coming to complete rest. Find the value of X. Nothing to worry, we'll just write the equation. Work done by conservative forces, gravitational force, work done by spring force plus work done by friction plus work done by external is equal to change in kinetic energy. Okay, final velocity is equal to how much? Final velocity equal to 0. It should come to rest, right? Completely rest. How it is started? It started from rest. Change in kinetic energy is equal to 0. Are there any external forces? No, 0. Friction is there or not? Yes, it is there. Work done by gravity. Gravitational force is acting in the downward direction. Spring is moving in the horizontal direction. Angle between 90 degrees. It is equal to 0. Now, work done by spring force and work done by friction. These two are left. Now, let's do work done by spring. Work done by spring is equal to minus half K final xf square minus xi square. What is the final compression of the spring? It's come to the natural position. So, final compression is equal to 0. Half K 0 square minus how much it is compressed? 2 meter. Half minus 4. The K value is given. K is equal to 200. Minus of minus plus 200 by 200 100 into 4 400. Work done by spring is 400 joules. Okay, K is equal to 200 and 200 by 200 and it is equal to work done by spring is equal to 400. Work done by friction. When friction starts working, see carefully. So from A to B there is no friction. From B it starts. So friction is equal to friction is equal to mu mg. The displacement is in this direction x. Work done by friction is equal to, both are in opposite direction, minus mu mg into x. Say let's the distance x is where body has come to rest. Understand? The distance x represents body has come to rest after the traveling x distance. Now let's write the equations. Work done by spring force is equal to, let's write values also, minus 0.5 m is equal to 16 into 10 600 into x. Okay, it's equal to minus 300 multiplied with x. Now work done by spring is work done by spring plus work done by friction is equal to 0. 400 minus 300 x is equal to 0. X is equal to 4 by 3 meter. After traveling 4 by 3 meter, the body will come to rest. We can change any number of questions here. Let's see the other question now. A vertical spring with a force constant K is fixed on a table. This is a constant K fixed on a table. A ball of mass m at a height h above the free surface. Now from here it's above. Upper end of the ball falls vertically on the spring so that the spring is compressed by a distance d. Find the net work done on in this process. Okay, we'll write the same thing. Work done by conservative plus work done by non-conservative. Conservative plus work done by non-conservative plus work done by external is equal to change in kinetic energy. Now where it started? It started from the height above. It is in the rest position. Initial velocity is equal to 0. Finally it is compressed. Final velocity also becomes 0 because it's compressed in a maximum d. So change in kinetic energy becomes 0. Okay, net work done. We are just calculating work done. As of now, no need of even velocities also. No need to calculate the velocities also. He is asking what is the net work done. Work done is equal to work done by conservative plus work done by non-conservative plus work done by external. Work done by gravity. This is the ball and here is the ball, and from here force is how much? mg. How much is the displacement it has undergone from initial position to final position? This is the final position, right? mg into total displacement is h plus d. Both are in same direction or different direction? Same direction. Work done by conservative. Gravitational force is equal to mg into h plus d. Then in a conservative forces there is no non-conservative forces, 0. External force 0. Work done by spring force is equal to minus half K xf square minus xi square. What is the final compression of the spring? It's compressed to how much displacement? d. Minus half K into d square minus initially compression 0. It's equal to minus half kd square. Let's write a total work done is equal to mg h plus d minus half kd square. This is the total work done. Okay, if they ask whatever, you can find. Now let's see the other question. These are the questions mainly on a spring, because I want you to give the confidence in you to solve any problems regarding work per energy. Everywhere we are using work energy theorem only. Work done by conservative, work done by non-conservative, work done by external is equal to change in kinetic energy. This is the only formula we are using till now. Most of the cases, any of the case, we try this formula, and then if you are not getting, if you do this way, after some time you will understand the concept. Okay. Now, system as shown in the figure released from the rest when the spring is unstretched. Initially spring is unstretched, pulley and spring are massless and friction is absent everywhere. Okay, very good. The speed of a block 5 kg when the 2 kg block leaving the contact with the ground. Remember, this point is very important. Block 2 kg block leaving the contact with the ground. Whenever a body is leaving the contact, then the normal becomes 0. Let's draw. So he is asking velocity of 5 kg when 2 kg leaving the contact, which means the velocity of 5 kg is depending on 2 kg leave. When the 2 kg leaves, that we should find. Let's draw the free body diagram. 2 kg and downward force is 20 Newton, upward force is tension. There is tension, and from the ground there is a normal. When is about to leave, normal is equal to what we discussed, 0. In this case, T is equal to 20 Newton. He did not say that it is moving with the acceleration. Okay, when it's about to leave, the acceleration is equal to 0. Okay, T is equal to 20 Newton. T is equal to 20 Newton. Then come to the spring part. Let's go to the spring part. Spring, what kind of spring it is? It's a massless spring. In this side there is a tension, and the other side there is a spring force. And so let's write the equation. We don't know how tension is related to spring force. Let's write Fs minus T is equal to mass of spring into acceleration. What is the mass of spring? Spring is equal to 0. It is equal to 0. Fs is equal to tension. So spring force is equal to tension if the spring is massless. Understood? If massless, what is the Fs value? Tension we got 20 Newton. 20 Newton, F is equal to K into X, right? Which is equal to 20. X is equal to 20 by K. K is equal to how much? K is equal to 40 as per the question. K is equal to 40. It is equal to half meter. It is displaced. Okay, spring is displaced half meter, which is nothing but who displaced in this section? 5 kg mass displaced in the downward direction. Understood? Let's draw the diagram. Spring and 5 kg on the downward direction. It is displaced how much? Half meter, 0.5 meter. Now we'll write the conservative work energy theorem. Work done by conservative gravitational plus work done by spring plus work done by external is equal to change in kinetic energy. Whenever you see velocity questions, just go through this formula. Work done by gravity, what is the gravitational force? mg, and what is the displacement? 0.5. Both are in same direction or different direction? Same direction. So plus mg into 1 by 2 plus this is work done by gravity. It is equal to work done by gravity. Work done by spring is equal to minus half K xf square minus xi square. Xf minus half K is equal to 40. What is the final compression? 1 by 2 square minus initial compression is 0. Okay, in this case it becomes 20, and 1 by 2 square become 1 by 4. It is equal to minus 5 newtons work done by spring. Now let's write m is equal to, m is known, what is the mass? 5 kg. 50 by 2 work done by spring is equal to, work done by gravity is equal to, m is 50, mg is 50, and 1 by 2 is equal to 25. 25 joules. Oh, okay, what is this? Newton's work done by spring is minus 5 joules. Work done by gravity is 25 minus work done by spring is equal to minus 5 is equal to change in kinetic energy half mass is equal to 5 v velocity v square, and this is what we need to find. 20 is equal to 5 by 2 into v square, that is equal to v is equal to root 8, so this is 40 by 5 and it is equal to 2 root 2 meter per second is the velocity. Okay, let's do the other question. A variable force P is maintained tangent to frictionless cylindrical surface. This is a radius A, okay, and a block weight W moved and a spring to which it is stretched from position 1 to position 2. The work done by force P. Now, slowly varying force. Remember, this statement should be highlighted. Slowly varying force, which is nothing but it is moving. The system is moving with constant velocity. So when you see slowly varying force, the process is slow, velocity remains constant. Now so when you see this question, you will be afraid like how to solve this question. It's as simple as like that. Just work energy theorem, nothing more. We'll write a work energy theorem. What is the work energy theorem? Work done by conservative, work done by gravity plus work done by spring plus work done by external is equal to change in kinetic energy. Now, what is the work done by gravity? Work done by gravity is equal to, now this is the mass. What is the mass? Mass is given, weight is W, mg is given directly, mg into height. How much height it was? So gravitational force is a conservative force. It doesn't depend on path. However, you take whatever path you follow, if it goes to certain height, that height, this is say a sine theta, this is the value. Mg h, this mg is nothing but W, h is equal to a sine theta. What is the direction of force? Both are in opposite direction. If you see, mg is in the downward direction, a sine theta is in the upward direction. The body has moved, so both are in opposite directions. It's minus W a sine theta. Let's see work done by spring. Work done by spring is equal to minus half k into xf square minus xi square. So conservative forces, they don't depend on path. Okay, they just depends on final and initial positions. Conservative forces. That's why that is the advantage with the conservative forces. Whereas if non-conservative forces are given, it becomes difficult to solve. Okay, let's see this question. Okay, xf final springs, how much is the stretch? Now, initially the first position is natural length for up to here. It's a natural length, it's not compressed or extended. The spring, it's a natural length. And how much it is extended? It is like a perimeter, right? It is extended up to here. You can draw like this. It is extended from here. The length it is extended is nothing but the perimeter. What is a perimeter formula? S is equal to r theta. S is equal to what is extension? R is nothing but a and theta. This is what the final position. Initial position is 0. Okay, xf is equal to a theta. I think you understood. Initially it is in this position. It is stretched. How much it is increased length? The perimeter of the circular path. Circular path is equal to r theta. R is nothing but a, theta is theta. So let's substitute the value. Xf is equal to minus half xf is equal to k into xf is equal to a square theta square minus xi is equal to 0 square. it is equal to minus half k a square theta square. If you write change in kinetic energy is equal to how much? 0. Let's write the equation. Work done by gravity is equal to minus w a sine theta minus half k a square theta square plus, there is external force or not? Yes, there is external force. The P is nothing but the external force. Okay, work done by P is equal to change in kinetic energy equal to 0. Then work done by P is equal to a w a sine theta plus half k a square theta square. These are the examples on a spring.